Keynotes are ready.
Hello again. Welcome back. So I'm just here for 1 minute, hopefully not much longer, just to introduce our keynote speakers, who are going to be Olivia Guest and Sam Forbes. They are joining us from various places online, so you'll be seeing them. Oh, you can already see Olivia on the screen, and their slides will appear here. So just to say very briefly who they are, Olivia is an assistant professor in computational cognitive science at the Radboud University in the Netherlands, and she is interested in the meta-theoretical, critical, and radical perspectives on neurocomputational and cognitive sciences broadly construed. Sorry, loads of long words there, but yeah, I think she's basically a computational cognitive scientist. And Samuel is a developmental psychologist at Durham University, and he's particularly interested in infant cognition, and he uses a variety of tools to be researching that. But the reason Olivia and Samuel are joining us today is because they wrote a paper recently called Teaching Coding Inclusively. If this, then what? And I found out about this paper and then recommended to whoever I met that they should read it. So some of us in the room have already read it. I think most of you would have received the link to it with your invitation to today, because we really think everyone should read it. And to give you even more reasons to read it, I think Olivia and Samuel will tell us more about why teaching coding inclusively is something we should all be doing. So that's me done. Thanks very much, and enjoy the keynote.
Wow, thank you so much for the lovely introduction. I feel like there's not much to say now. So yeah, my name's Olivia Guest. My co-author's name is Sam Forbes. And yeah, this is the title. So teaching coding inclusively, if this, then what? I work in an artificial intelligence department as an assistant professor. Sam works in a psychology department, also as an assistant professor. And I think a tiny maybe backstory before I give the story proper is that I think over the last 10 years or however long I've been teaching other people to code, is that certain themes or patterns show up regardless of sort of department or setting. And these are the ones that I want to sort of unpack a little bit today. But before that, I just want to give you an overview of everything that I'm going to say, because I also want to say a little bit about me, because I think some of my background, educational experiences might be useful. And then, yeah, dive in. It's really directly talking about, so what actually is going on in programming classes? What is it with all the sexism? What are the specifics of what's going on? Where are the women coders? What are the mechanisms that might lead to this? And what can we do about this as educators? So specifically focusing on our role as teachers of people who want to learn how to code. And then I want to hand over to Sam to say his part, all on the same topic, of course. So yeah, originally I'm from Cyprus. Some of the issues that we're going to discuss, or that I'm going to discuss today, weren't necessarily present when I was a child. So that might also give me a bit of a perspective. When I moved to the UK for my undergrad to do computer science, some things really reared their head. Of course, that doesn't mean that in other countries outside the UK or outside the global north, or however you want to phrase it, the Anglosphere, don't exist. So it's not that sexism doesn't exist, it's just that it might manifest in slightly different ways. Then I did a master's degree in cognitive and decision sciences, and then a PhD in psychology. So I've worked mostly in psychology departments, in some other places. I also moved back for a bit to Cyprus, and then finally where I am now. So I'm in the Netherlands at the Donders Institute at the Radboud University. So that's just to give a bit of a background about my own experiences and sort of where I'm coming from pedagogically. So yeah, to really jump in here. So what is it with all the sexism? So if you work in a similar department to me, so I work in an AI department, I have responsibilities with respect to the programming line. So with respect to teaching programming, even though I don't directly teach programming myself, I help with the designing of courses and so on. it's a non-controversial point, I think, that there's some kind of problem with respect to gender. When we think of like who is a coder, we have certain preconceived ideas, and maybe people in this audience don't, but I'm sure you're aware of what people might be thinking. But on the other hand, women were the first computers, so computer used to be a job. In fact, this statement is a little bit untrue. It's not that women used to be the first computers, but when computers, the job, the profession, existed in the 40s and 50s, it was predominantly women. In fact, in the Middle Ages, it wasn't. But in the 40s and 50s, women made up this workforce that were called computers, and eventually they got automated and their jobs were replaced by digital computers. And when that happened, women were also the first programmers. So women innovated in the 50s and 60s and created the profession of programmer. So here we go. So they invented programming. This, of course, wasn't in the last century, but the one before. Ada Lovelace could be called the first programmer, even though she never had access to a computer. And even if she had access to the sort of pre-computer computer that she was working on, the analytical engine was the one that was programmable. Before that, it was the difference engine. None of these were digital. So she worked with these analog computers and wrote the first program. And yeah, like I already mentioned, women also invented the profession of programmer in the 1940s. So they used to be computers, and then they became sort of the users, the creators, and the innovators of computing. So they did both. But like I said, the modern stereotype is something entirely different. And also the relevant academic and industrial settings are actively hostile to women and feminized people in general and other minoritized people. So there's something going on here. We're wholesome, although I wouldn't describe my department necessarily as wholesome, but we're trying our best. But there's a larger setting here of gender pay gaps and of stereotypes in society in general about who is competent at, in fact, STEM subjects in general, and maybe even specifically for programming and using a computer, being technologically adept in general. But really, essentially, like I've already touched on, it's just not the case. So here are just some examples from the past. We see here two women working on core rope memory. So this was the memory that they used for the Apollo missions, and these women manually created this piece of hardware that had hardwired software, if you want to think of it that way, it's firmware, of course, in it. And this was in the 60s and 70s, sorry, the 50s and 60s. And also in the 60s, we have these three women here. So Patsy Simmers, Gail Taylor, Millie Beck, Norma Steck, who were mathematicians and programmers, and they were involved a lot in the first general purpose computers. So the first general purpose digital computers were sort of their full-time profession. Another example from the late 60s and also relevant to the moon missions was the code that Margaret Hamilton and her colleagues wrote. And here she is standing next to this printout here. So why, if I can find, I mean, you have to take my word for this, but if I can find all of these examples really easily and more, and there's many, many more indeed, where are they? So why are they not the first things that come to mind? And what comes to mind is, I don't know, a more masculine coder. And the answer is, unfortunately, some of it is by design. So there was an intentional pushing out of women and of rewriting the historical record. And yeah, it was done purposefully. If people want to read more about this and not just stay with a pessimistic message, but read a whole negative history, but maybe it's good to do that. There's a book by Ma Hicks, and in their book, they essentially talk about the specific case, the specific case of Britain, although this is a pattern that is across sort of the Western world. This specific example here, though, is an in-depth book, and it talks about how women were strategically pushed out from the profession of programmer. Right, and here is also a graph that shows the percentage rather of women in studying different fields, and we see the same pattern. And I think this data is just from the US. So this is showing an example from not from the UK, but from the USA. And here we see that in computer science, sort of roughly after the early 80s, the early to mid 80s, women were sort of between 35 and 40%, and then it sort of starts decreasing, and the percentage of women choosing to study computer science is nowhere near other sort of comparable in prestige degrees. And of course, there's no specific reason for this to happen other than some forces actively pushing the women out, especially since we know that there were many women active in coding and generally in computer science. So that's something to bear in mind when we think about what things might be happening in our classrooms, or what stereotypes people might be having in their head to force them to pick a different subject. Right, and something else that I want to touch on that is a bit more zoomed out is some work that I did with Lelia Erskoy and Annelies Klein-Herenbrink, which is talking about this much more general pattern, so not specifically for coding, but for women being replaced by inanimate objects, which obviously includes the digital computer. And this is something that has happened throughout the history of computer science, where we have here in sort of the 1890s up until maybe the 1940s and a little bit later, women doing these jobs, like I already mentioned, so women being computers and women being coders, to women being replaced both by computers themselves, the digital computer, the inanimate object, replacing the women, and by men. So their job was seen as prestigious enough to be replaced by men. And that's kind of the story of the previous, the book by Ma Hicks, and the previous patterns has this kind of theme that repeats. And in this paper, we talk even more about these trajectories, but the general idea is that especially in the past, there was a lot of women involved in these things. So, and that brings sort of a frame that students might be carrying with them in the classroom. So what can we do as educators about this pattern? So one thing is not just to think about the history, which might have these like very pessimistic results given the figures and facts that I've given you, but also think about the present. So there are a lot of people, women, who are doing things, and I'm sure you can think of your own colleagues or yourselves or your own environments, but these are important things to like bring to bear into the classroom, where people where our students are not academics. They don't know about colleagues who are computationally competent, or they don't know about what kinds of things you can do when you know how to code, or how coding isn't necessarily some elitist activity. So we can remind them that there are people who are active in the present and are women or people of color. But also, and we have this in the paper, is to confront the ideas that maybe our students actively share with us. So, and obviously to create a space for them to do that. So here's one example that I heard a couple of years ago. So a student came to me and said, I'm too old to learn to code. Others started in childhood. And to be honest, I don't remember exactly what I said, but here is like an idealized answer that someone could give. So you could say something like, many learn to code and many other complex skills later in life. But also, programming basics are not novel concepts. So we're kind of reminding them that these things are not somehow out of their reach, out of their cognitive abilities. So if statements, if you're hungry, then you can have a snack, while there are slices of pizza left, offer them to your guests. Object orientation, a dog is a type of mammal, so you can typically expect it to have 4 legs. An orca is also a mammal, but has modified legs for aquatic life. So that's like something that they would learn maybe in a more advanced setting, but clearly it's not that cognitively different to how they might be thinking about the world in general. Also to remind them, I guess, if they bring up age, that age is not actually relevant. To remind them that people may be gatekeeping. So those who use their prior much younger exposure to code are gatekeeping you on purpose. They're not warning you of real educational dangers, but purposefully using this false excuse to stop you learning. Unlike some facets of cognitive development, there is no critical window for learning to code. This is a myth. Especially this last part, I've heard, unfortunately, even from colleagues. So I do computational modeling. And I've heard from other computational modelers saying this kind of myth about, oh, I learned to code when I was 7. How can people not learn how to code? So clearly this is being maybe brought up by the student here. Another example is women are not good at programming. So someone just says it, whether the person who says it is, regardless of their gender. I've heard this being said by people, including when I was doing my undergrad, and I'm not sure I had a good answer at the time, but here's like something idealized that an educator could intervene and say this. So if you think this, then can you explain how a woman invented the compiler, wrote the code that took humans to the moon, and on and on? If these are somehow exceptions to some baseline where most women are not that good at coding, I can grant it if you also grant that most people are not that good. Not everybody is an expert writer or mathematician, but girls excel at these subjects much more than boys in primary and secondary school. Something else is going on that contorts your view of women as competent coders. So this is also very much the case in my artificial intelligence department, where we have sort of a 40-60 split of women and men, roughly. And quite often we see that when we create the right environments, the gender differences disappear. But of course, creating the right environment is the challenge. And here's another one that was particularly upsetting to me. I heard this from a final year student. I do not know how to code, even though I'm in my final year of an artificial intelligence bachelor. So this is impossible. It's completely impossible, because she wouldn't have been able to get to her final year. And yet this is what she believed. So I said, why do you think this one is real? This one is a direct quote from me. That's why the emoji looks like me, I guess. Why do you think this, given you have passed all your programming classes? That is the university's definition of knowing something, which might not mean much, but what metric are you using? Stereotypically polluted perceptions of women coders taken from your classmates, teachers, or society at large. Remember, the coding you do is real coding. So this is a case where someone has basically been coding full time as part of their academic career for the past 3 or 4 years. If they're in their final year, I think in our case, this might have been a 4th year student. So we allow a 4th year sort of due to the structure of our course, you can be in your 4th year and still be an undergrad. And she really just thought, even though she was passing her classes, because otherwise she wouldn't be in her final year, that she didn't know how to code. And I think these kinds of examples, thinking through these different dialogues, especially when you have these problematic situations with respect to how people perceive themselves or their classmates, the educator needs to sort of intervene. So we need to sort of be on guard. And on that note, I just want to hand over to Sam. So I'm going to stop. Yes.
And I will start sharing. So while I do that, thank you everyone for being here. I have no idea what's just happened. Okay, you can hopefully see that.
Yes, we see your slides very well.
I'm going to sort of minimize all the random Zoom stuff that's popped up. So I don't know, somebody shout if there's questions, but otherwise we'll answer stuff at the end. So thank you all. So I'm going to follow on basically from what Olivia has been saying and the context that she's been giving. I'm trying to give also slightly the flip side of that, and I'll explain what I mean by that in just a second. But also alongside this, I guess I want to point out that, as Olivia said, I'm a developmental psychologist. That's actually really important for the context I'm going to give today. And I will also tell you why in a second. So I'm just going to keep secrets from you at this point, and then we'll carry it on. So I just want to start with, again, reiterating what Olivia has said, right? So the state of the field, generally speaking, if we're talking about how people perceive coding in society, what we think about coding, is that at best, coding has an image problem. At worst, if we're being explicit about it, coding has a sexism problem, right? There may be many other problems as well, and these things are going to be intersectional, but this is what we'll focus on for now. Many tropes exist. We've got the sort of male geek trope, and you'll sort of all be able to recognize the kind of, flawed genius who is not a particularly nice person and socially inept that you'll see, in sort of Sheldon Cooper on the bottom right. Now, in science, if we move away from sort of people who code, full time, coding is at the very least useful, if not sort of necessary, for jobs that we do. And this can lead to really unequal outcomes. If you think about the fact that we sort of say, okay, coding is really important. If you're hiring, for example, in academia, if you're looking to hire a research scientist or hire a postdoc or something like that, you might prefer someone who can code. And the people who can code are the people who weren't pushed out of coding earlier in their career. So as you start to sort of go up the scientific ranks, you're going to be more and more likely to end up with men rather than women. Now that's a problem. That's obviously a huge problem. So Olivia's already given a lot of this context, but just to reiterate, we know that women were the first coders, first computers, first programmers, and in many cases have been erased from the history of the field. We know that, when you think about what children think about coding, if you sort of say, imagine a computer scientist or whatever, more often than not, they're thinking about men. We could ask the same thing, I'm sure, to ChatGPT and get all sorts of nonsensical or offensive answers as well. And this is where I sort of mentioned that, we might want to think about the flip side of this as well. So what happens when we move away from, for example, AI departments, which is, the context that Olivia was giving? In a more feminized field, coding has been considered less important, right? So what do I mean by this? If you look at AI research, roughly 1 in 4 authors were women. And that number was even smaller in senior or first author positions in these publications, right? In psychology, by contrast, it's roughly 75% to 80% female. And this is where as a developmental psychologist, I'm coming from quite a different perspective here, because developmental psychology is much, much more exaggerated here than general psychology, and much more exaggerated than, for example, neuroscience, which has become more masculinized. So, okay, that's all well and good. You know, you might say, okay, coding is considered less important in psychology. But is coding really useful in psychology? And, you know, this is kind of an open question. You might say, well, okay, not strictly. I'd like to argue that it definitely is. You can imagine there's all sorts of random contexts where we might want to be using it. We might be doing computational modeling. We might be doing statistics. We might be sort of doing things like experimental design. We might be doing things like all sorts of things. So we might be collecting, you know, at any facet of our sort of data generation, data creation, analysis pipelines. This is pretty crucial. And again, there's an advantage if you can do these things. You might be able to find someone else to do them for you, but, you know, there is an advantage if you can do it yourself. So these are places where one might use coding, right? But you might still ask, okay, you can use it, you can code, but is it strictly necessary to be able to, you know, do your job? So this is where it becomes tricky, because the psychologists who can code often have an advantage on the job market. There are more opportunities for authorship. You can imagine people looking for someone to help them with stats, people looking for someone to help them program experiments, and so on and so forth. So there's an advantage in authorship. There's an advantage in getting jobs, as I highlighted earlier. There's an advantage in, you know, potentially even down the line, things like grants and things like this. So you end up with sort of the haves and the have-nots. And because of these tropes, because of the way we've pushed people out, we've pushed women out, because of the way, you know, people sometimes talk about a leaky pipeline. It's an obstructed, deliberately obstructed pipeline, right? This is often gendered, right? And so you end up explicitly hiring or giving advantages to men because of what we're looking for and because of the way that we've taught and shaped the field. Now, the other side to, you know, when we think about who can code, what opportunities do we have when we're coding, is, okay, Olivia's given some great examples of people who do code, right? We know that women did some of the first coding, etc. But what quickly happens, especially, you know, in a lot of scientific fields, has happened quite a lot, is once things become popular or become heavily used by women, they suddenly become less serious. We downplay them. So, you know, puzzle games are often then thought not to be true coding games. They're just, you know, silly toy examples. HTML, suddenly people will talk about it being a not real coding language. If you're too active on science Twitter, like I sometimes am for my sins, what you sometimes then find also is people from other coding language backgrounds sort of saying, well, yeah, okay, you can do some stats with it, but it's not real coding, not in the same way as something else, something that manly men use, you know? And so it's quite easy to then diminish what people do. And yet we know some of the most hardcore, most badass, if you'll forgive the turn of phrase, examples of coding have, of course, been done by women. Now, when we minimize contributions the way that I've sort of pointed out here, when we sort of say, oh, well, you know, this isn't a real example of it, you know, sure, you can put together some R code, but are you a coder? No, you're not. When we do this, is it any wonder that we sort of diminish any kind of enjoyment of coding? And of course, once we diminish the enjoyment of coding, once we diminish these contributions, that, of course, leads to less exposure to coding. I mean, if you're being told that what you're doing isn't real and isn't worth anything, why would you bother, right? And, you know, it really entrenches this gatekeeping, which Olivia highlighted. So, you know, this idea that, oh, well, so-and-so has been coding since they were 7. How can you possibly catch up to them? When, A, maybe the goal isn't to catch up to them, but to do the things that you need to do. And B, this should be, and we're here in many cases as sort of educators who want to teach coding. This isn't a failure of the student. This is a pedagogical challenge. These are the students we should be working with. These are the sort of outcomes that we need to be looking at. Teaching someone who can code to code, much less interesting, right? Now, again, coming back to being a developmental psychologist, I study infancy and sort of early development. Now, admittedly, sometimes in human development and in animal development, there are what we call critical periods, periods where if you don't do things in this certain window, then you miss out, right? And a lovely example here in the bottom right of Lorenz and his ducklings, where he taught them to follow him around by being there in that sort of critical window immediately after birth. Coding is not a core developmental skill. If you want to teach ducklings to follow you around, then yes, of course, you have to do this in this critical window. If you want to learn to code, and particularly, to do the things that you need to learn how to do, and this is what's important, right? To be functional here, there's no critical windows. We don't have to do this by the time we're 7. So this is really, really an important concept. There is no time window in which case, if you haven't learned in there, then you've missed out. And this is, my own experience is that as well. I learned to code during my PhD. So definitely no critical window. What does this look like in the classroom? Well, some recommendations that we might want to think about, right? One is, and I touched on it earlier, you want to avoid only catering to the most experienced students. It's tempting. There's a nice payoff when you get to the end of the class and you're like, hey, look, these people are so good, right? But if they've started ahead and they finish ahead, then, that doesn't necessarily need much contribution on the part of those of us who are teaching, right? And one nice thing you might want to do, if someone is way ahead of the class and they're bored, why not have them learn about the history of the field from an EDI perspective? Have them think about what is the history of coding. You can give them other tasks here, and that, rather than sort of just teaching them to get further and further and further ahead of their peers. Now, the other thing that's tempting, as I say, you get to the end of the module, you get good module evaluations, you've taught a lovely class, you've got some nice comments, job done, right? And this is where we always want to be really, really, really careful. And I've actually gone and spot checked this with a few different coding courses. And one of the things that often happens is you get sort of reasonable to good module evaluations. But the people who got excluded right at the beginning of the module, who felt like they didn't belong, then disengaged to the extent that they never went back and did things like the module evaluations, right? So who's dropping out, and also who is just completely disengaging? Don't assume that these good evaluations mean that we're doing our job well. Always keep in mind, what are we doing and for whom are we doing it, right? One thing that is, I think, important is to avoid pretending that these structural problems, like sexism, like racism, is simply absent and sort of brush over it. It can be useful to address these problems for the field upfront and discuss why it is. And this ties into the next point, which is about framings such as imposter syndrome, right? Sometimes it's useful to sort of be able to say, look, you aren't behind. And that's often, the message we're trying to convey when someone sort of doesn't feel like they belong. But it's very easy for that to turn into, this is all in your head, right? Whereas what you want to be saying is, yes, okay, the reasons you feel like you don't belong, the societal sort of image that you've been given, the structural sexism, the structural racism, they exist, right? So we've got to think about this in a way that avoids this sort of victim blaming mentality. The imbalances are out there. So sometimes that structure isn't the one that we want to think about. It can be useful to show humility as a teacher. And I like some of the examples I saw earlier today as well. You know, this idea of sort of live coding or deliberately coding in like typos and things like that. There's also, you know, one nice idea. But it is really important for the students not to see the instructor as a genius who knows it all, who can, you know, magically solve any problem. And I could never be like them, if you know what I mean. It's really, really useful for them to see that, like, yes, this is a person with more experience, but this is just another person working their way through the code, same as I'm going to do. And that really gets rid of that sort of magical, you know, I will never obtain this kind of level. One point that I think is an interesting recommendation, which not necessarily everyone I think will agree with, is code challenges. Competition can be fun. It can be fun to do something pedagogically, like, you know, hey, who can be the first to do this? How often is that pedagogically useful, I would ask? I think more often than not, it's not necessarily, because again, you'll get a bunch of students who will decide that not only are they not going to win, which might be disheartening, there's no point even taking part because they were never going to get close. And that can just demoralize students who are learning. So really empowering students to care about each other's learning, not just their own learning, really matters. And showing up matters, pointing out the great examples, as Olivia has said, in the field, that, you know, are making huge contributions, and really highlighting that, I think really, really, really matters. So that's all from me. Thank you.